Hello boys and girls, so we have question 6. A power transistor is a solid-state electronic device. So we assume that energy that entering the device at a rate of 1.5 volts by electrical transmission causes the internal energy of the device to increase. The surface area of transistor is so small that it tends to overheat. So means that bila kita ada power, when we supply power of 1.5 volt to the transistor, because the surface of the transistor is very small, so it tends to overheat. So overheat means the transistor are going to have high temperature. Okay, so the transistor have high temperature. So to prevent overheating, untuk elakkan transistor tu jadi terlalu panas, so the transistor is attached to a larger metal heat sink with fins. So kita akan sejukkan transistor tu dengan kita attachkan dia kepada satu metal heat sink. So the temperature of the heat sink remain constant at 35 degrees Celsius under steady state conditions. So kita akan sambungkan transistor tu kepada satu metal heat sink di mana temperature untuk metal heat sink ni akan remain pada 35 degrees Celsius. So heat akan flow daripada transistor yang high temperature ni pergi ke arah metal heat sink yang mana temperature dia lebih rendah lah, pada 35 degrees Celsius. So the transistor is electrically insulated from the heat sink by a rectangular sheet of nickel measuring 8.25 mm by 6.25 mm and 0.0852 mm thick. So transistor ni tidak connect direct kepada metal heat sink, tetapi in between transistor dengan metal heat sink ni, dia ada satu kepingan rectangular sheet of nickel, di mana dia punya kita akan pisahkan gunakan satu nickel, di mana dia punya di mana it is a rectangle whereby the dimension is 6.25 mm times 8.25 mm. Okay, so dari situ kita boleh cari area lah. We can find for the area. And the thickness of the nickel, so the thickness of the nickel is 0.0852 mm. So the thermal conductivity of nickel is equal to 0.0753 watt per meter degree Celsius. So we want to find the operating temperature of the transistor. So kita nak tahu berapa temperature untuk transistor tu. Okay, so kita faham transistor is overheat, dia ada high temperature, dan metal heat sink ni dia punya temperature adalah lebih rendah, maintain pada 35 degrees Celsius. So it means that there will be heat conductions. There will be heat conduct from the transistor towards the metal heat sink across the nickel. So there will be thermal conduction occurs across the nickel. Okay, so the heat will flow from the high temperature transistor towards the low temperature metal heat sink. So we want to find the temperature of the transistor. So we are going to apply the thermal conduction equation. dq over dt equal to negative Ka dt over dx. So the rate of heat flow here is equivalent to the power that's supplied to the transistor lah. So it will equal to 1.5 negative. So the thermal conduction occurs inside the nickel, across the nickel. So the thermal conductivity for nickel is 0.0753. The area of the nickel, so because the nickel is a rectangular sheet, so area untuk segi 4 kita boleh kira dengan kita darabkan dua-dua sisi dia. So we have 8.25 to the power of negative 3 millimeter change to meter multiplied with the another side 6.25 times 10 power of negative 3. Okay, so we get the area for the rectangular sheet of nickel. Then the temperature difference The temperature difference will be the temperature of metal heat sink and the temperature of transistor. So we have 35 minus the temperature of the transistor over, so the difference of the two temperature is across the nickel. So the thickness of the nickel is 0.0852 to the power of -3. Okay, so tinggallah temperature. So we left with the temperature that we need to calculate. So tinggal mathematics, we will solve it and then we will get the value of the temperature for the transistor.